Hey everyone, welcome back to my channel. Guys, in this video we are going to practice this sheet metal bracket. Here you can see on my screen. So this is the sheet metal bracket. This is the sheet metal piece we are going to practice today, and I'm going to keep it here. Here you can see this is the piece image that I had pinned on the top of my Fusion 360. So it will be always here for our reference, and we are going to model this particular sheet metal piece inside Fusion 360. And in this video I'm directly going to start this sheet metal piece. I'm not going to show you how you can save your project, how you can rename it, or how you can create new projects and all these things, because I had already shown these things in my old videos. If you want to learn that, you can just check out that video. Link is in the below video description. So let's move on to Fusion 360 and start modeling this sheet metal piece. So here you can see, as we had already saved our drawing file with the name of sheet metal practice exercise 13, and it's already saved inside our YouTube folder, YouTube sheet metal folder. So I will just close this data panel from here, and here you can see if I will check it from here, behind our image there is nothing. That's why I had kept it here. I'm also going to make my image little bit smaller, so all the things will be visible to you very clearly. So now we are completely prepared and we'll start modeling this part inside Fusion 360. So here you can see this is my Fusion 360 default screen. Whenever you will first launch your Fusion 360, it will look something like this. So we have to move on to sheet metal workspace. So over here, if I click on the sheet metal name over here you can see the workspace has been changed. Now we are into sheet metal workspace, and by default there is a already empty component has been created. This is the parent component. So this is by default always created. Whatever the name you are going to give to your file, that will be assigned to this particular name. So this also can be hidden from here if you want to hide it, or you can open it from here. So this is actually called design tree, where all your file is structured based on the steps you are taking. And below over here, here you can see this panel. This panel is for design history. So whatever the steps or whatever the process you are going to follow to make your sheet metal design is getting captured over here. And in the top right corner you got a view cube from where you can navigate across your 3D model, or you can also navigate across your 3D model using your mouse and keyboard. So don't worry about that. So now we'll move on to our image. Here you can see this image that we are going to create today, this sheet metal piece. So for this sheet metal piece I'm going to consider a thickness of 1 millimeter. So before starting, there are few things you have to take care inside your Fusion 360 design or drawing. The first is that definitely the document settings, where the units must be correct. We are going to follow the units millimeters, where you can see it's millimeter right now, so it is correct. If you want to change, you can just click on here and change it. Next thing is, guys, the sheet metal rules. From here inside the modify panel, here you can see this is my sheet metal rules. If I click over here, I can check my sheet metal rules. So we got multiple kind of sheet metal rules over here, and most of the times we're going to use this cotton steel or stainless steel, so or aluminum or steel, whatever you want to use. Even in millimeter and in inches, in both system of units, you will be able to find your defined sheet metal rules library inside Fusion 360. So I will just close it from here for now. So guys, so now we are going to create new sheet metal rule for us. I will just click on the sheet metal rule. I will go on to the cotton steel, stainless steel. We are going to use the stainless steel, and if I expand it from here, you can see it's for the 6 mm thickness. So we are going to change that. So we'll edit and change that to 1 millimeter of thickness, and the K factor we are going to keep 0.44, and the rest of the settings, because we don't want to change the other settings, so we'll just keep the other settings as default. Only we are going to use the change the thickness, and we'll click on the save. So you can see the stainless steel settings has been changed, and now I will click close. Now the first thing is that we had to consider base flange on this drawing. So this face here you can see, this is the face that we're going to consider as a base flange. So I will start creating that particular flange, and all the dimensions and details I'm just going to consider in this drawing. So I will click on the create a sketch tool from over here, and here you can see now I have to select the diff plane on which I want to create my sketch. So I will just select this front plane as a sketch plane. Here you can see the moment I had clicked on the front plane, all my sketch tools are active. Now I will go on to create panel over here, and inside the create panel, if I expand, here you can see I got a rectangle tool, and if I go on to rectangle tool and click on this small arrow, I am able to select 3 different kind of rectangles. From here I will select center rectangle tool, here you can see, and I will select the origin as a 1 point and drag it outside to make a rectangle. Here you can see. For this particular design, I am going to take 100 millimeter of the width of this particular rectangle, and the height will be around 60, like that. Here you can see, and I will press enter on my keyboard to accept. Here you can see, if you had not defined the dimension, no worries. Let's say we had not defined the dimension, I will just select these dimensions and delete from my keyboard. So to define those dimensions, what I can do, I can just click on the sketch dimension tool from here. So the sketch dimension tool is active. I will just select the sides and will drag outside and will press enter to accept the results. Here you can see, so these are the values I had assigned to both the sides of the rectangle, and it is completely defined. Once the sketch has been turned to black, this shows that the sketch is completely defined. You can also check this inside your sketch folder. If you expand this, here you can see this small red lock icon. This shows that my sketch is completely defined. So it's always good practice. So whenever you are creating a sketch, try to define your sketch completely. That's the only way you will not mess around your 3D model. So now what I will do, the next thing is that we're going to create 3 holes over here, and then will this slot and 3 more holes over here. So for that I will just activate my circle tool. Here you can see center circle tool, and I will create a circle like this. So since they are just 3 holes, so I will just randomly create 3 holes like this. Here you can see. Now what I will do, I will select the center of all the 3 holes. Here you can see, just press shift on your keyboard and you will able to select all the 3 entities at once, and then I will apply this vertical constraint. So this will make sure that all my 3 holes are on a vertical direction, same vertical direction. So here you can see, if I try to move the one circle, all of the 3 are moving. This shows that all of them are on same vertical direction. So the next thing is that we had to apply one more constraint. Before that I will just select the 3 circles. Instead of selecting centers, this time I am selecting the circles parameters. Here you can see, and then I will apply the equal constraint. So this way I had made all the 3 circles as equal sizes. Okay, and now the next thing is, guys, is that I want to tell you one more thing. Like whenever you are working in sheet metal domain, there is few things that you always have to take care of whenever you are creating any circles. Here you can see, since we are creating these circles for the holes, so whenever you are creating any hole on your sheet metal, any sketch for to make a hole on your sheet metal, always try to make it 3 times distance from the sheet metal thickness. First I will define the diameter of this circle. So I will activate my sketch dimension tool. I will select one of the circle and I will define the diameter as 5 millimeter. Yeah, 5 is good. So you can see 5 millimeters dia of all the 3 circles, since they were applied with the equal constraint. That's why I just had to define one of them. Now what I will do, I will define the distance from the boundary, one of the edge. So I will just select the edge and then select the center of one of the circle and will drag outside like this. So this is the dimension I'm talking about. So right now you can see the radius of this particular circle is 2.5 millimeters. So I will just write 2.5. Then I have to make sure that it is 3 times away from the sheet metal thickness. So sheet metal thickness is 1 millimeter we are going to consider. So it will be 1 into 3 like this. Here you can see, and I will make sure that it is following the rule of the mathematics. And so here you can see, and it is 2.5 plus 1 into 3, right? So it's not into, it's this symbol is like this inside any of the softwares. So if I press enter, here you can see it is coming 5.5. so this is the exact rule for defining to making holes on the corners of the sheet metal. So this is the thing you always have to consider, that the minimum distance must be 3x of the sheet metal thickness. Here you can see the next thing is that we have to define the distance between these 2 circles, these 3 circles. So we'll define the distances. So this one I just want to keep 10 millimeter like this, and again this one is again 10 millimeter like this. Here you can see this was very easy. And we have to define one more thing from the top to this first circle. So this one I just want to keep 10 like this. Here you can see. Now the next thing is that we have to create this slot over here at the center on the bottom area over here. So for that I will just go on to over here, create panel tool, then we'll go on to this slot option over here. Here we got this center slot. I will activate this one. I will create the first point and then go horizontally, and then we'll create the second point and we'll drag it out like this. Here you can see, so it's completely free to move on inside our space. So because it is not defined, so we're going to define it now. For that, first I will define the diameter of this radius of this particular slot. So this one I just want to keep 5. So here you can see, and then I will make a line like this from origin to this line on the midpoint somewhere. Here you can see this triangle icon shows that we are on midpoint, so I will just click on that. Here you can see what I will do. I will make this line as a vertical line, and then I will define it with the dimension, the size of this line. So this distance I just want to keep 15. Here you can see, and then I will define the size of the slot, width of the slot. So this width is, I just want to keep 40 like this, and then I will change this line to construction line because this I don't want this to be a very firm line. So here you can see these things and these things we had already created. Now we'll move on to creating these 3 holes, these 3 small holes. So those are very small holes, so we'll follow the same practice that we did for the other side of the hole, since they are also 3 holes like this. And we'll select all the 3 holes and we'll apply the equal constraint like this, and then we'll make sure I will select the center of the holes again, and we'll apply the vertical constraint to make them in on the same line. And now what I will do, I will define before defining the distance, first I will define the diameter of this circle, one of the circles. So this one is just 2 millimeter. Here you can see. Now I will define the distance from the center of the circle to the edge. So this one is the radius of this particular circle, and plus 3 mm distance from the edge, since the thickness is 1 millimeter, or so if we multiply it with 3 times, so it will be 3. So 3 plus 1 equal to 4. Here you can see. And now I will define the distance from the bottom is, so this one I just want to keep it 20 like that, and from the top is, this one I also want to keep 25 like this. Then we'll define between these circles. So this one I just want to keep 10 or maybe 6 like that, and then just delete this one, this bottom dimension, and again make it 6 from the other circle like this, 6. And here I can see that yeah, it's good. So we had created these circles also, these 3 circles. So now we can just click on the finish sketch and we can move on to our next step. I also forgot to tell you one more thing, like whenever you are defining the distance between the circles, distance between each circles, there is a rule. That rule is that the distance between both the circles must be minimum of 6 times the thickness. Since the thickness is 1 millimeter of this particular sheet metal, so the hole must be 6 millimeter away from each other. So we'll check how much distance circles we have right now. So I will just click on this measure tool. We'll select these 2 circles to check all the distances. So here you can see right now it's 5 millimeters. So we need at least 6 millimeters, 6 times the thickness. So for that we had to increase this one to 11. And this one also 11. And guys, we had to change here also, because we'll check first whether it is correct or not, and then we'll change. Here you can say it's 4, so minimum we had to do 6. So for that reason we had to increase it by 2 millimeter more, so we'll make it 8, and this one also 8. Here you can see. Now I will just click on my finish sketch, since we are done with the sketching, and now I'm going to convert that to a flange. For that, what I'm going to do is I will activate this flange tool and will select the region that we want to convert to flange. And here you can see a 1 millimeter sheet thickness has been converted. If I see it from the side view, here you can see right view, here you can see this is 1 millimeter thick. So here are few of the options when you are converting your sketch to flange you have to take care of. The first is the profile that we had selected. Then we had to check the orientation, whether we want to give it a thickness of 1 millimeter on this side or on the other side. So we can change it from here like that, or if we want to make it center, we can do that also. So in our case we are going to keep it as a side 1, and operation we are going to keep it as a new body, and the sheet metal rule that we are going to apply is stainless steel that we had already customized. So you can see that we had just converted our sketch to flange. Now the next thing is that, and there is a problem guys, here you can see the thickness is very high. Right now our current sheet metal thickness is very high, so we just want to change our thickness. So this is the beauty of sheet metal, you can change the thickness of your model or object at any point of time. So I will just go on to the sheet metal rules, click on here, and here you can see in this design we are using this stainless steel sheet metal. So I will just click on this pencil icon to edit this particular rule, and here I will just change our thickness to 0.5 millimeter, and we'll click on the save. Here you can see everything got updated. I will close this one, and here we are. So now we are going to make this open hem over here. So for that we'll activate our flange tool. We'll select this particular edge and we'll make an edge like this, and this one I just want to keep maybe 3 millimeters, and here it is. And once you will start creating flange from edges, you got multiple different options, like you have to define the height of this particular edge flange that you want to create, then the angle. If you want to change the angle, you can change it to, if you want to bend it towards upward or downward, you can just change this angle. Since it's 90 degrees, so it's just extending that particular edge to 90 degree. And then the height datum, if I change this to here, you can see how the things will orient. It will not be visible right now because the height datum will not work here, but the bend position will work. So bend position right now you can see it's inside, completely inside, and if I change that to outside, it will update like this. So and if I make it adjacent, it will move a little bit further, and like that. Tangent is little different. So in most of the cases we are going to use our inside bend position, and we can also flip the direction. If you want to flip make the bend on the other side, you can flip it. So I will just keep it on this direction, because as per our image, as per our drawing or design, we want to make this particular flange like this only. So these are the rules that you have to follow in all of your sheet metal flange operations. So there is one more thing, like is if you want to make this complete edge as a flange, then you can do that as a full edge. Or if you want to make it maybe little bit smaller, like you don't want to make a flange of complete edge, you can change that also. So here you can see you can control the dimension and we'll able to change it from here. So we got multiple options over here. So for our current design, we are just going to keep it as a full edge, and I will just press OK on 3 millimeter. Now you can see that whatever the steps or the design process I'm following is getting recorded over here inside the design history. So anytime if you want to make any change, you can just come over your design history or the step, make a right click, and you will able to edit the features. Now again we'll activate our flange tool from here, and we'll select this edge as a flange, and then we'll make it extrude like this, flange bend like this, and this time I just want to make it 2 millimeters, and we'll press OK. Here you can see we had created one more flange towards upward because we had to create this shape. We'll again activate the flange tool, we'll select this internal edge, and we'll make a bend like this towards inside. So this one I just don't want to keep it more, I just want to keep it little smaller, maybe 2 millimeter like that, and we'll press OK. So you can see the height is little bit higher, so we'll try to decrease that, or else what we can do, we can increase this particular flange little bit longer. So for that we'll go on to that particular flange, we'll make a right click, we'll click on the edit feature. So we had made it 3 earlier, so we'll change that to 4 like this. Here you can see, and here is the shape we got. It's called open hem flange, and we can I think it's almost near to our design what we had right now. So we'll just keep it like that. So I already told you that open hems are made to make your design safer to use, also stronger at the edges. That's why we used to do folds like this on the edges. Now the next thing is, guys, we had to make this particular flange. So for that again we'll activate our flange tool from here, and we'll check that particular edge, select that particular edge, and we'll make a flange like this. So this one is, I believe it's around 30 millimeters. So yeah, it is 30 millimeters, so I will keep it as a 30. So I'm just approximating the dimensions. Here you can see this is looking a little bit longer in our case, so we can change that also. For now we are just keeping a flange of 30 millimeters, and we'll press OK. Here you can see now we'll try to change this particular height of this face. So that can be changed by changing our base sketch. So that is this first sketch 1. I will make a right click on this particular sketch and click on the edit sketch. Here you can see, and we don't want this height to be 60 is very high, so we'll change that to 40 only. And once we are making it 40, here you can see some holes are going outside, so we have to adjust that also. So I will make a slot little bit above, so for that we'll change that to 15 to 10, maybe like this. And here the holes we want to move it a little bit higher, so we'll make it 15 as well. Here you can see the holes are moving or little bit higher as well. Let's just make it 12 like that. And once I will click finish, here you can see my complete design is updated. So that is the beauty of using Fusion 360. From the design history approach, you can change your design at any point of time. So it's quick and easy, very easy guys. It's just on your fingertip. So the next thing that we are going to create this particular teardrop hem. So for that first we had to create a flange shape like this. So for that what I'm going to do is activate my flange tool from here, and here I will select this edge. I told you that if you don't want to make a flange of your full edge, you can just change it from here. So I will just change that to here as a symmetric, and distance I will just make it as a 15, or I think 15 will work. Let's try to do that instead. Or okay, yeah, it's working. So instead of 90, I just want to make it 0 degree first. So instead of going to 4 millimeter, I will just go to up to 3 millimeter height. Here you can see, or let's just make it 4 millimeter like that, and we'll press OK. There you can see the same. Now again we'll activate our flange tool, then we'll select this flange like this. So instead of going a height of, I will just make it a 2 millimeter height. Here you can see, and I will press OK. Now again we'll activate our flange. So sheet metal is all a game of flanges, so I just had to keep creating flanges. So here you can see I will just make it this one as 5 millimeter, and we'll press OK. Now I had to make a teardrop hem over here. So for that reason I had to activate my flange tool again. We'll select this bottom edge and we'll make a flange like this. So this time I just want to keep 2, and we'll try to see from the right whether we are touching the body. Yes, we are touching. And we can just also we can make it 1.5, it's touching, so it will look good as well. Or maybe 1, I think we are crossing, or 1.5. okay, 1.5. I'll just press OK. Here you can see. So here you can see, since this is touching the edge, if I see from the right view, I had to make this height as little bit higher. So for that reason what I can do, I can change my old flange that will give it a more height to little bit higher, maybe 3 millimeter, and we'll press OK. Here you can see. Now if I go into right view, I can see there is a gap, so that worked for us. Now I will activate my flange tool again. We'll select this particular edge and we'll make it like this. Here you can see, and it's not coming since this height is very less. So again I will increase the height of this particular flange. So this one I just want to keep 2 millimeter, and then we'll activate our flange tool and we'll select this particular edge. And now I will try to make a flange like this. Yeah, it's working guys. So I will extrude it to maybe 2 millimeter, and instead of extruding this to 90 degree, this time I will use maybe 130 or maybe 100 degree. So here you can see how it's coming. So I will go on to right view to make a teardrop hem, and first I will increase it to 3 millimeters, and then I will make it 120 degree or something, or maybe 110 degree. Yeah, 110 degree is working great guys. So this much of bend we'll able to achieve, and we'll press OK. So this type of bend is called teardrop hem, and here you can see this type of bend is called open hem. So all of these two type of hems are to give the thickness, give it a strength to the edges, and also to make it safer to use. So here you can see these are the two. This is the flange that we had just created. Now the next thing is that we have to create this particular feature. So for that what I will do is I will just click on this top particular face, and we'll click on the create a sketch. And here you can see we are into a sketch environment. Next what I will do, I will go on to create panel tool and activate my center rectangle from here, and we'll create a rectangle like this. So we are going to make it cut on this particular body. Here you can see. So I had created a random rectangle. We don't know the size, so for now I will define the size from origin to this top edge. We just want to keep 20 millimeters, and the width of this particular thing we just want to keep 60, or maybe a little bit higher guys. 70 will work, I think. Yeah, 70 will work. And we'll click on the finish sketch. Here you can see, and this is our result. Now I will activate my extrude tool. We'll select this particular profile, complete a rectangular profile, and we'll drag it towards the bottom like this. up to -8 mm and we'll press OK to make a cut. Here you can see. So this is the shape we had created. So it's looking like this, guys, right? Now the next thing is that we had to create this kind of shape over here, and then we had to create few more holes on this top. So the first thing that we are going to do is first we'll create a flange. So we'll activate the flange tool and we'll select this particular edge. Here you can see this edge, and we'll try to make a symmetric edge, and instead of let's just extrude it and we'll change that to 90. Instead of 90, I just want to make it 0. I just want to go parallel, and instead of distance 35, I just want to make 15 like this, and I just want to go maybe 7 millimeters higher or maybe 5 millimeter higher. Here you can see, and we'll press OK. So this is the face we had created. Now again we'll activate our flange tool. We'll select this particular edge and we'll make a flange of thickness maybe 8 millimeter and we'll press OK. Here you can see. So this is the result we got. Now here you can see the corners are all filleted, so we'll apply the fillets. So for that reason I will activate my fillet tool. I will select all the corners that I want to apply fillet. So one corner, two corner. If you don't know how to apply the fillet, you can see this video. It's very easy to apply fillet. Just select all the corners that you want to apply, and whatever the edges you are selecting to apply fillets, here you can see it's getting recorded. We had selected 5 edges so far. 2, 1, 2, 3, 4, and then 5. And then this one is 6th edge. And we'll select 2 more corners, these sharp corners. So there will be total 8 edges. Here you can see 8. And then we'll apply the fillet radius. So fillet radius I just want to keep 5, and if I zoom out, here you can see we are applying the fillet radius of 5. So 5 is I think higher, guys. Just make it 4 or maybe 3 or maybe little bit lower. Maybe 2 will work. Yeah, 2 is fine I think, and we'll press OK to accept the result. Here you can see. Now the next thing is that we have to create this particular shape. So again we'll use our flange tool, and instead of using the full edge, what we can use is that symmetric, and instead of we'll just apply the distance. So whatever the distance is applying, the flange width will be double of that. So if I give it 10 or maybe 20, the flange not 20, okay, let's just make it 20 and try to extrude like this. Here you can see. So right now here you can see it's first from the image it's first extended little bits towards the forward parallel to the edge. So here I will just make it 0 degree and will make it 2 millimeter kind of thing extended towards the edge parallel to the face, and we'll press OK. So first little bit extended, then again we'll activate the flange tool and we'll select the edge, and then it is going towards downward, but not at the 90 degree, it's on the 45 degree. So here you can see like that, and this time I just want to keep it as 3 millimeter, and then again it is going 90 degree towards the bottom. So again we'll activate the flange tool and we'll select the bottom edge and we'll extend it like this. So if I go on to home view, so we'll able to see better. So this time I just want to go 1.5 millimeter, or not 11.5, I will just go 1.5 and we'll press OK. So here you can see this is the shape we had created. So we had to change one thing here. This width is very small, so for that reason I will just make a right click and we'll click on the edit feature and we'll extend it a little bit, maybe 4 millimeter or 4.5 millimeter like that, and we'll press OK. So now it is looking very good, very similar to this particular design. So you can see that how easy it was to create this particular design. So now I will start creating these all holes. So for that reason again I will select this particular face and will activate this sketch tool. Here you can see we are now ready to create a sketch on this particular face to create these cuts, circular cuts. So for that reason I will create circles like this, one over here, one over here like that, and then again one circle over here and one circle over here like that, and I will make sure that and one more circle over here. Here you can see we also got one circle over here. Now what I will do, I will make sure that these 3 circles are equal in size. So I will select these 3 circles and I will apply the equal constraint from here. Here you can see all three became equal. Now I will apply these two circles as equal circles, so these two circles are equal. Now I will make sure that this circle center point and this circle center point are on vertical direction, and we'll apply this circle center point and this circle center point on vertical direction. So here you can see. Now what I will do, I will make sure that this circle center point and this circle center point on the same horizontal position, so we'll apply the again same constraint, and this circle center point and this circle center point on the same horizontal position. Now I will define few of the dimensions. From edge of the center of the circle, we just want to keep it as 6 millimeter. Here you can see, or maybe a little bit higher, 7 millimeter. And I will define from this top edge to this circle, I just want to keep 6 millimeter. Then from this center to this center, I just want to keep 15, like that. It was very easy. So we'll repeat the same process on the other side. This one is 7 millimeter, and that's it, guys. We just had to define the diameters. So I will activate my sketch dimension tool. We'll select this sketch and we'll define it as 7 millimeter, or maybe a little bit higher, maybe 8 millimeter. And again we'll activate our dimension tool. We'll define this particular circle as 5 millimeter. So you can see these four are constraints since they are completely defined. The only thing we had to do is we had to define this particular circle, since you can see this is not fully constrained. So what I will do, I will select the center of this circle and the origin of the complete design, and will apply this vertical constraint. Here you can see. Now I had to define the distance. So from here to here I just want to keep maybe 4 millimeter, like that. So now you can see all of the sketches is completely defined, and this small red icon on the sketch shows that this complete sketch is completely defined. There is nothing dimension left. So I will just click on the finish the sketch over here, and here you can see I am ready to make a cut. So I will just activate my extrude tool. Will select all the circles that I want to make a cut, and will drag it towards the bottom to make a cut like this. Here you can see, and if I press OK, and we had made a cut like that. Now only thing that we had to make cut on this face of this small circles over here, you can see. So in this particular feature here, you can see this edge, these two edges are also filleted. So here we will again activate our fillet tool. We'll select these two edges since they are very small fillet radius, so we'll just apply fillet radius of 1 or maybe 1.5 will work, and we'll press OK. So here you can see these two are all filleted. While making these holes, we had not followed the sheet metal basic rule, that what are the distance we had to follow to keep these circles away from the edges. We had not followed those things, but I had already told you that how you can make your sheet metal designs to more stronger and more sturdy for the practical application. Next thing, the only thing that we had left is this making these holes that we are going to do now. So what I will do, I will just activate my sketch tool from here, then we'll select this face where we want to create that particular holes, and then the only thing that we had to create these circles. So for that I will just create one circle like this anywhere on this on this face. Then we'll define this the position of this particular circle by dimension tool. So I just want to keep 3 millimeter, let's say, and then I will define the diameter of this particular circle. So I just want to keep it as a 1 millimeter. What I will do is here you can see the circle is not fixed, so the next thing is that we had to also define it from the edge. So this one I just want to keep maybe 1.5 millimeter, and we'll click on the finish sketch. And here you can see I will activate my extrude tool and will make a hole like this. Here you can see I just made a cut, and now I'm going to pattern this particular hole by 6 number of times. Here you can see that. So I will just select this particular feature from on the design history tab. Then we'll go on to the create panel over here. Then we'll go on to pattern. Here we got the rectangular pattern that we're going to activate. Here you can see the feature is already selected, this feature. Here you can see, and we'll select the axis. So this is the axis along which I want to feature my patterns, and then we'll give it numbers. So this one I just want to keep 6, and then the distance we had to give. So I will just go on to the front view first like this, and then we'll give it a distance of 30 millimeter like that, or maybe 35 or maybe 31. I just had to check which is working great. So I think 32 is working great. I will press OK to accept the result. So here you can see this is the hole we had created. So now if you want to apply any appearance on this, you can just go on to modify panel and activate the appearance tool. So here you can see I had just activated the appearance tool. This is my appearance tool. I can select any of the glossy finish materials and just drag it on our material to look it like that. So you can see I'll just make it look like a sheet metal. So this is our final design that we had created. And if I move my image from here you can see, and let's keep it somewhere here. And if I want to make a flat pattern of this particular thing, so how we can do that? So for that, what I had to do is just click on this create flat pattern tool, activate this tool. Then I want to keep this face as a fixed face, and if I press OK, here you can see Fusion 360 will create a flat pattern for my design. And if I click on the finish flat pattern, so this is my final design. So anytime if I want to activate your flat pattern to see the designs, you can activate that. So guys, this is the final design of our sheet metal part. So let me know if this tutorial was easy to follow. If you have any questions or doubt, just comment below in the video. I will try to answer all of your questions and doubts in the comment below. Also, if you are new to this channel, subscribe to this channel because I will keep creating contents like this. Thank you guys. Thanks for watching.